Hey everyone, so in last two lectures we talked about normal distribution and standard normal distribution. So both the lectures were theoretical lectures. Okay, I didn't take any examples in either of the two lectures. So both were conceptual lectures. If you have not seen those lectures, make sure you have a look. It will help for better understanding. So today's session will only be on problem solving session. So I'm going to solve around 4 to 5 examples. We will start with the simplest one and then we will go for little bit of moderate level examples. And all the examples that I'm going to take today, they are from the Walpole book, Walpole Mayers and e-book on probability and statistics. So I'm going to take problems from that exercise section. So that's the reference. So let us start with the first question. So the first question is, given a standard normal distribution, you have to find the area under the curve that lies to the left of z equal to minus 1.39. So here is the normal curve I have tried to draw. I mean, it's a symmetrical one. It doesn't look like, but yeah, it's almost symmetrical. I tried to draw this. So here is the normal, standard normal curve with mean 0 and standard deviation 1. You want to find the area to the left of minus 1.39. That means you are supposed to find this area. Okay, and this goes towards minus infinity. So one way is what you simply do the integration of the PDF, so which is nothing but 1 upon root of 2 pi integration minus infinity to 1.39 e raised to minus of z square by 2 dz. But again, instead of doing this, we are going to use a table. So if you see any book or even in the exam, they will be providing you with the tables. So here again, I have taken the tables from the end of the book. So now here you can see this at the top right. This is, so what are this number? They are the area from minus infinity to z. That is what this number represent. Okay, and they have gone from minus 3.4 to plus 3.4. Now in our case, what is the scenario? The scenario is minus 1.39. So if you go for minus 1.3 is here, and then you go for the ninth column, means 0.09, which is the last one. So answer is 0.0823. So answer in our case will be 0.0823. So that's the answer for the first part. What about the second part? You want to find the area to the right of 1.96. Okay, now let us try to see the figure for this. So to the right of 1.96. So where is 1.96 over here? If you see somewhere over here 1.96, and you want to find this area. So what you can do is, we know that it's a PDF. PDF means what? You find from the table what you will get. You get probability for z less equal 1.96. This is what you will get from the table. That means you will get from this much area till 1.96 to the left of 1.96. Whatever answer you get, you subtract 1 from it. Okay, so in this scenario, if you see what is the area to the left of z equal to z less equal 1.96. So if you try to go to the table 1.96, so if you go at the bottom 0.9750, so it is 0.9750, that is to the left, but you want to the right, but we know it's a PDF, therefore probability of z greater equal 1.96 will be 1 minus 0.9750. You subtract, you get the answer. That is one way to do. Another way to do is, we know that this is symmetric in nature. Symmetric in nature means what? Whatever the area will be there on the right of z equal to greater equal 1.96, the same area will be here minus 1.96. That means the same area will be towards the left of minus 1.96. So if you go to the table and you look for the value of probability of z less equal 1 minus 1.96. The answer which you get over here and the answer which you get over here, both will be the same answer. Okay, so you can go it either way, it's up to you. Okay, now let's go for the next question. So in the third part, you have to find the area from minus 2.16 to minus 0.65. Okay, so again from minus 2.16. Okay, so if I try to draw this, minus 2.96 to minus 0.65. So this is the area that I want to find. So from here to here. So again, we have seen earlier that how to solve that. So probability from minus 2.96 less equal z less equal minus 0.65 is nothing but you find the area towards the left of minus 0.65. you get a complete thing, and then you subtract it from probability of z less equal minus 2.96 minus you subtract this much part over here. When you do the subtraction, you get the answer. And now I have already told you how to find these values. Okay, so you look for 0.6 and then 0.05. That's what the answer for this is. And again for minus 2.9 and go for 0.06. Then you get the value of this. If you can't find this, you can let me know in the comment section. I will help you on how to find these values as well. Okay, so this were the first three parts of the given problem. Now the remaining three parts are also similar. So if you try to solve these three problems to the left of minus 1.43 or to the right of minus 0.83 and between minus 0.48 to 1.74, you try to solve these three problems on your own and then you can check the answers. And if you want, you can just post in the comment section. I will check the answers for you as well. So these are the basic questions that one can expect on standard normal distribution. Now let's go for the second question. So here the question is, you have to find the value of z so that the area under a standard normal curve to the right of z is 0.3622. Okay, so let me try to just write it down on the open board, 0.3622. So this is what the question is, right? But because this is given to the right, that's why greater equal, but we know that this is nothing but 1 minus probability capital Z is less equal small z 0.3622. So if you take probability Z less equal Z on the right hand side and 0.3622 on the left hand side, you have 1 minus 0.3622 and on the subtraction you get 0.6378. So what is this number 0.6378? It is the probability of Z less equal small z. So now you look for this value in the table. Okay, you can't directly look for this number in the table because this is the area towards the right of z, whereas tables give you the answer towards the left of z. So where is 0.6378? Let us try to look that. So here if you see the table, here you can see 0.6368 in the picture. Okay, so here you can see it is 0.63 in the 6368 in the picture. There is no 0.6378, but you can see this circle one is a number which is closer to 0.6378. So you will take z to be 0.35. So that's the answer for z. And z is nothing but 0.35. Okay, now B part is what you have to find the value of z such that the area under the standard normal curve to the left of z is 0.1131. Now here no need to do that adjustment 1 minus because here the area to the left is given. So you simply go to the table and try to look for 0.1131. So here you can see if you observe you get 0.1131 is here, which is how much z equal to minus 1.21. So answer is z equal to minus 1.21. Now let's go for the next problem. Okay, now in the C part, the area is given from 0 to z, which is nothing but 0.4838. Now this is again not completely towards the left of z. Okay, they're only taking the positive one. So how will you solve this problem? Now we know that total area under the curve is 1. So that and this curve is symmetrically distributed. So on the right hand side the area is half, on the left hand side the area is half. So here it is given only from 0 to z. So what will be the area from minus infinity to 0? It will be half because it's half and half. So you want to find z such that area towards the left of the z is 0.4838 plus 0.5, so which is 0.9838. So again you go to the table and look for 0.9838. So if you look towards the table, this is 0.9838. So it is 2.01234. So it is nothing but 2.14. So that's the value of z for the third part of the answer, for the third part of the question. And now in the fourth part, what is the question? The area from minus z to z, it is 0.9500. Now what will be that z? That is the question. Now here what we do is, again we take the help of the C part. Now minus z to z it is given to you. So what will be the area from 0 to z? You simply divide this by 2, right? Because it is equally distributed. Area is equally distributed. When you divide this by 2, you get 0.4750. You get 0.4750. What is this number 0.4750? It is the area from 0 to z. Now we know that what is the area from minus infinity to 0? 1 by 2. Okay, so the area from minus infinity to z will be how much? 0.5 plus half of this, which is 0.4750. So 0.4750 plus 0.5, you get 0.9750. So you have to simply look for the value of z such that the area is 0.9750. So if you look at the table over here, 0.9750. So answer is z equal to 1.96. So that's what the answer for the fourth part is. So I hope this is clear. If you have any doubt, you can just ask me in the comment section. Okay, so now let's go for 6.7 question. Now this is same as that, but let me just give you the hint. You have to find the value of k so that probability for z greater than k. That means area towards the right of k is given to be 0.2946. So if you want to use the table, you should have z less equal k. So this is nothing but your probability of z greater than k is 1 minus probability of z less equal k. So probability of z less equal k is 1 minus 0.2946. Now whatever answer you get, you use the table to find the value of k and comment the answer in the comment section. Similarly for B part, now B part no need to do 1 minus. Since it is already given probability of z less than k, you simply go into the table and try to look for which value of z it is taking the value 0.0427. What about the C part? We use the property of PDF. For the left hand side, it is probability of z less than k minus probability of z less than minus 0.93. From the table, you find the answer for the probability z less than less equal minus 0.93, and then take it on the right hand side, you get the probability of z less equal k. And again from the table, you find the value of k. So that's the hint for 6.7. You can just pause the video and try to solve it. It will give you, a good confidence. Okay, here is the next question, 6.8 question. So now here a normal distribution with mean 30 and the standard deviation sigma is given to be 6. Now this is not a standard normal distribution. This is your x distribution. That means the x score is given to you. You want to find the area, normal area under the curve to the right of x equal to 17. Okay, but now we know that probability that x is less equal 17 is same as probability of z less equal z1, where z1 is the z score for x equal to 17. And how do you go do the transformation? In the last lecture we have seen, you take x minus mu upon sigma. So 17 minus 30 upon 6. So what is 17 minus 30? It is minus 13. So minus 13 upon 6, which is nothing but minus 2.167. So let me write it down so that we remember. So what I'm saying is, now here you have to use the z score. So your z is nothing but x minus mu by standard deviation, which is minus 13 by 6, which is minus 2.1667. So that's your z1 score. So probability that x is taking the value less equal 16 is same as probability z will take the value less equal minus 2.1667. And this you know how to find, because now again we are in this standard normal distribution. So now use the table and you can find this value. So let me just try to solve this problem for you. It is minus 2.1667. So if you go over here, so minus 2.1 and then you go for the 6 value. So 0.0154. Or if you want to just approximate, so you can take 7 also. So it is minus 2.17. So answer will be 0.0150. So that's what the area under the curve. So now what is the question? Question is probability that x is taking the value greater equal 16. But this is same as probability z is taking the value greater equal minus 2.1667. But that is 1 minus probability of z less equal minus 2.1667. Okay. Now you go towards the table. So if you go to table over here, minus 2.17. So it is 0.0150, 0.0150, and when you subtract this, you get the answer. So whenever the question is towards the right, you always do 1 minus. So that's one thing you have to take care of. Now if you see the B part, it is given towards the left of. So no need to do 1 minus. So the question is towards the left of x equal to 22. So probability of x less equal 22 is same as probability of z less equal the corresponding z score. What that will be? 22 minus 30 upon 6. What that will be? Minus 8 by 6. So do the division and you get some fraction, and then directly use the table. No need to do 1 minus. Okay, what about the C part? You want to find the normal curve area between x equal to 32 and x equal to 41. So you find the Z1 score and the Z2 score for x equal to 32 and 41. Okay, so what is the thing? So your x1 was 32 and x2 is 41. So your Z1 will be x1 minus mu upon sigma, Z2 will be x2 minus mu upon sigma, and these are your Z scores. Okay, so therefore probability that your x will take the value from 32 to 41 is same as probability your Z will take the value between 0.33 to 1.83. And now this I'm not going to solve. This is nothing but probability of Z less equal 1.83 minus probability of Z less equal 0.33. You simply solve this from the table, you get your answer. Okay, so that's how we are supposed to solve the third part. Okay, now what is the fourth part? You have to find the value of x that has 80% of the normal curve area towards the left. Okay, 80% means how much? 0.8. So in the table, try to see where do you get 0.8. So here you can see 0.8 is here. Now which one is closer to 0.8? This one is closer to 0.8. So your z will be 0, 1, 2, 3. It will be 0.83. So the value of z will be 0.83. So for that z equal to 0.83, area towards the left of z equal to 0.83 is almost the 80%. Okay, so that's the answer for the third part. What about the, sorry, that's the answer for the fourth part. What about the fifth part? Two values of x. That's it. Okay, wait. In the D part, you have to find the value of x. What I gave you was the value of z. But once you have the value of z, it's easy to find the value of x, right? How do you find the value of x once you know the value of z? So your z is nothing but x minus mu upon sigma. So what will be your x? It will be z sigma plus mu. Okay, so what answer did we got? We got 0.83, right? That was the value of z. Into sigma is given to be how much? 6, and mu is given to be 30. So using that, you will get the value of x score. Okay, using that you get the x score. So be careful what is asked in the exam, whether the z score is asked or the x score is asked. And now for the last part, two values of x that contain the middle 75% of the normal area curve. In the middle area is 0.75. So first we take the help of z1. We first find z1, z2. From then z1, z2 we find the value of x1 and x2. Now the middle part contains 75% of the area. Okay, so this is your normal distribution curve. Okay, you have to find this z1 and z2. So this will be symmetric, so no need to worry. This will contain 75% of the area. Means this is nothing but 0.75. So probability that z1 less equal capital Z less equal z2 is nothing but 0.75. But then again what you do is, we know that this is equally distributed. So what you do is, what will be this much area? You divide this by 2. This will be 0.375. And we know what is the area towards the left? It is half. So you add 0.5 to it. So you get 0.875. Now in the table, look where is your z equal where is 0.875. So you can see this is the nearest one, 0.875. Only 0.001 is missing. So it is 1.15. So it is z equal to 1.15. So your z2 is this, and your z1 will be what? Minus 1.15. Now for this z1, you find the corresponding x1, which is z1 into sigma plus mu, and for this z2 you find the corresponding x2, which is z2 sigma plus mu. So that's how you will get your x score. So here is the next question. So the average life of a certain type of small motor is 10 years. So sigma mu is given to be 10 and sigma is given to be 2. The manufacturer replaces free all motors that fail while under guarantee. But now if the manufacturer is willing to replace only 3% of the motors that fail, how long the guarantee should be offered so that his objective is attained? Okay, now she is willing to replace, and you're assuming that it follows normal distribution. Now if she is willing to replace only 3% of the motors, So you go to the table and try to see the area under the curve is 3%. That means 0.03. Now if you go towards the table, 0.03 will come over here. Now if you go towards the table, 0.03. Now where do you think, where does it come? 0.03. If you observe, it comes over here. Right, that's the nearest one, 0.03. So it is minus 1.88. So we know that z is x minus mu upon sigma. We know that it is minus 1.88 x minus how much your mu? Your mu was 10 and your sigma was 2. So from here your x is 10 plus 10 minus 2 into 1.88, which is nothing but 6.24 years. That means around 6 years and almost something 88 days. Okay, because in a year there are 365, can assume. So this much guarantee should be given so that the manufacturer will only replace 3% of all the motors which are failed. So that's the answer for this question. So here is the last question. So soft drink machine is regulated so that it discharges on an average 200 milliliters per cup. And if the amount of drink is normally distributed with a standard deviation equal to 15 millimeters, so sigma is given to you and average mu is given to be 200. Okay, what fraction of cups will contain more than 224 millimeter? So I will give you the hint for this. You want to find the probability of x greater than 224, which is 1 minus probability of x less equal to 224. But now this is your x1. You find the corresponding z score. How will you find x minus mu upon sigma? So 224 minus 200 upon 15, which is 24 upon 15, which is 1 point something. So you have to find probability that z is greater than, how much we got, 24 upon 15. You find that fraction. So z greater than 24 by 15 is 1 minus probability of z less than 24 by 15. And now I think you can use the table and get the answer. Probability between the cup contains 191 to 209 millimeters. So for this x1 and x2, you find the corresponding z1 and z2. So z1 for 191 will be corresponding to 191 will be 191 minus 200 upon 15. You get minus something. And z2 will be 209 minus 200 upon 15. So now again I think you can use the table and you can get the answer. How many cups will probably overflow if 230 milliliter cups are used for the next 1000 drinks? Again, now for this 230, you find the z score and use the table to get the answer. So I think this much hint is sufficient. You should not be give complete hint, otherwise you won't be thinking. So yeah, try to solve this problem, and if you get the answer, post in the comment section. And if you have any doubt, you can again ask me in the comment section. So I hope this much problems are sufficient on how to use the table and how to solve the problems given in X distribution or the Z distribution. If there are some other problems which you want me to solve, then you can ask me in the comment section. I will take out time and try to solve those problems as well. So yeah, thank you.